Okay. Good morning. Can you hear me?
Good morning, sir.
Good morning. Okay. අනිත් එනකම් පොඩ්ඩක් පොඩි කතන්දර කිහිපයක් තියෙනවා කියන්න. එනරි. sorry. ඒ තමයි පුතේ අපි ඒලොල් කරද්දී ගොඩක් වෙලාවට මේ ඉංග්‍රීසි මීඩියම් කට්ටියට තියෙන පොඩි ලිමිටේෂන් එකක් තමයි අපිට ඕනේ ටෙක්ස්ට් බුක්ස්. සාමාන්‍ය සිංහල මීඩියම් කට්ටියට නම් සිංහල මීඩියම් වල ටෙක්ස්ට් බුක්ස් ඕනේ තරම් තියෙනවා. මේ ප්‍රොෆෙසර්ස්ලා ඊට පස්සේ මේ ડોક્ટર පොස් තියෙන කට්ටිය. කියන්නේ ඒගොල්ලෝ ලියපු හොඳ පොත් තියෙනවා. නමුත් අපි ඉංග්‍රීසි මීඩියම් ගත්තොත් එහෙම ඉංග්‍රීසි මීඩියම් කට්ටියට තියෙන එක පොඩි ඩිස්ඇඩ්වාන්ටේජ් එකක් තමයි ඒ වගේ පොත් නැති එක. හැබැයි ඔයගලන්ට ගොඩක් හොඳ පොත් මේ කීපයක් තියෙනවා. ඒ ටික ඔයගලන්ට අවශ්‍යතාවයක් තියෙනවා නම් අනිවාර්යෙන් හැබැයි මේ රෙෆර් කරන්න ඕනේ පොත් ටිකක් තියෙනවා. ඒ ටික අනිවාර්යෙන් කරන්න ඕනේ. මේ අනිවාර්යෙන් මේ පොත් ටික පුළුවන් නම් හොයාගන්න. හොයාගෙන රෙෆර් කරන්න. ඒ කියන්නේ අනිවාර්යෙන් කියවන්න. තාම ඔයගලන්ට ඒක ලොකු පාඩම් ටිකක් අපි කරලා නැති නිසා මේ ගොඩක් වෙලාවට අපි යාන්ත්‍රික විද්‍යාව වගේ පාඩම් කරන්න පටන් ගත්තට පස්සේ මේ පොත් ටික අරගෙන මේ තියාගන්න. මම පොත් ලිස්ට් එකක් දෙන්නම්. මේ පොත් ලිස්ට් එක එකපාර ඔක්කොම ටික හොයාගන්න ඕනේ කියනව නෙවෙයි. නමුත් මේ හිමින් සැරේක හොයාගන්න ලබන අවුරුද්ද වෙනකොට අනිවාර්යෙන් තියෙන්න ඕනේ පොත් ටිකක් තමයි මම මේ කියන්නේ. ඒ කියන්නේ 24 වෙනවා. දැන් ඔයගොල්ලෝ 25 ලියන්නේ 24 වෙනකොට ඕගොල්ලන්ට මේ පොත් ටික හිමින් සැරේ අරන් තියාගන්න. විශේෂයෙන්ම බුක් ෆෙයාර් එක එනවා. බුක් ෆෙයාර් එකේ අපිට අඩුවට ගන්න පුළුවන්. ඔය මේ මං ගිය අවුරුද්දේ මට මතකයි මම පාස් පේපර් පොත් ගත්තා. පාස් පේපර් පොත් රුපියල් 100ට තිබ්බා. බුක් ෆෙයාර් එකේ කියන්නේ ඇත්තටම පාස් පේපර්ස් ටියුට් ටික ගහලා දෙනවට වඩා ළමයට ලේසි පාස් පේපර් පොතක් අරන් දෙන එක ඒ තරම් ලාභයි. රුපියල් 100යි. ඒ කියන්නේ අර මොනවද මේ බුක් ෆෙයාර් එකේ තියෙන වෙනම පැත්තක් ඔය බාගේන් බුක්ස් කියලා බාගේන් බුක්ස් වලට ඒ ස්ටෝල්ස් වල මේ බොහොම ලාභයට තිබ්බා. ඒක නිසා මේ මම මේ පොත් ලිස්ට් එකක් දෙන්නම්. ඒ පොත් ලිස්ට් එක ඕගොල්ලෝ හිමින් සැරේ හොයාගෙන තියාගන්න. හරි. මේ මොකද ඕගොල්ලන්ට තියෙන අර ලිමිටඩ් සෝසස් ටිකක් තියෙන්නේ. ලිමිටඩ් සෝසස් ටිකෙන් හොඳම ටික තමයි මේ ටික. හරිද? පළවෙනි එක තමයි ප්‍රොෆෙසර් රෝසගේ MCQ රිවිව් පොත් ටික. MCQ රිවිව්. MCQ රිවිව් මෙයා MCQ රිවිව් බුක්ස් දෙකක් ගහලා තියෙන ඉංග්‍රීසි මීඩියම්. එකක් තමයි 2002 2010 then 2011 to 2020 සිංහල මීඩියම් නම් මේ ප්‍රොෆෙසර් රෝසගේ මේ කියන්නේ ෆුල් පේපර් එක රිවිව් කරපු මේ පොත් වෙන වෙනම තියෙනවා. ඒ වුණාට ඉංග්‍රීසි මීඩියම් වල තියෙන්නේ මේ බුක්ස් දෙක විතරයි. මේ එකක් තමයි මේක. අනික මේක. ඒ කියන්නේ MCQ රිවිව්ස් විතරයි ඉංග්‍රීසි මීඩියම් දැනට තියෙන්නේ ප්‍රොෆෙසර් රෝසගේ. අතරම මාරම වටින පොත් දෙකක්. තාම ඕගොල්ලන්ට මේක තේරෙන්නේ නැහැ. මොකද තාම ඕගොල්ලෝ සිලබස් එක ගොඩක් කවර් වෙලා නැති නිසා. නමුත් අපි මතක තියාගන්න අපි මේ ක්ලාස් සීරීස් එක කරගෙන යද්දී සාමාන්‍යයෙන් 1994 වල ඉඳන් මේ 2024 දක්වා ඒ පාස් පේපර්ස් ටික අඩුම ගානේ අපි මේ 3 පාරක්වත් කරනවා. අඩුම ගානේ 3 පාරක්වත් කරනවා. ඒක නිසා අනිවාර්යෙන් හොඳට මතක තියාගන්න. මොකක්ද එකක් අපි මේ තියරි ක්ලාසස් කරනකොට තියරි ක්ලාසස් වල දැන් ඕගොල්ලන් හිතන්නකෝ යුනිට් ඇන්ඩ් ඩිමෙන්ෂන්ස් ඉවරුණා කියලා. යුනිට් ඇන්ඩ් ඩිමෙන්ෂන්ස් ඉවරච්ච එක මම අනිවාර්යෙන් මම ඔය දීපු පේපර්ස් මේ මම දීපු එක ටියුට් එකේ ඒ ටියුට් එකේ පුතේ ගොඩක් පාස් පේපර්ස් තියෙනවා. කියන්නේ පාස් පේපර්ස් මේ up to 2020 වගේ තියෙනවා. හරිද? දැන් එතකොට එකපාරක් ඕගොල්ලන්ට කව වෙනවා. ඊළඟට අපි ඕගොල්ලන්ට මේ next year 2024 වලදී අපි පටන් ගන්නවා රිවිෂන් එකක්. ඒ රිවිෂන් එක ගත්තොත් එහෙම පුතේ රිවිෂන් එකේදී ආයෙ පාරක් කරනවා. ඊළඟට ඕගොල්ලන්ව පටන් ගන්න පේපර් ක්ලාස් එකක්. ඒ පේපර් ක්ලාස් එකේදී අනිවාර්යෙන් කරනවා. මතක තියාගන්න දැන් මගේ ක්ලාසස් වෙන කට්ටියට පේපර් ක්ලාස් රිවිෂන් සාස් කියලා වෙන වෙනම charge කරන්නේ නැහැ. ඔක්කොම එක charge එක තියෙන්නේ. මේ ඒ හැම එකම ඕකේ මම ටියුට් ටික පෝස්ට් කරනවා. මේ මට ලබන සතියේ දෙන්න මට මේ සතියේ මම පෝස්ට් කරන්න මට පොඩ්ඩක් බැරුණා. ලබන සතියේ මම ඕගොල්ලන්ගේ ටියුට්ස් ඔක්කොම ටික පෝස්ට් කරනවා. මම මේ ඒක තියාගෙන හිටියේ මේ පාඩම අද මේ කරනකම් යුනිට් ඇන්ඩ් ඩිමෙන්ෂන්ස් පාඩම කරනකම් මොකද ඒ ටියුට් එකත් එක්ක ඔක්කොම එකපාර මට පෝස්ට් කරන්න පුළුවන් නිසා. හරි. මේ මට මතක තියාගන්න ඔය මේ ඔයගොල්ලෝ හරි ඇඩ්‍රස් එක දෙන්න. හරි. ඔයගොල්ලෝ හරි ඇඩ්‍රස් එක දීලා තියන්න. මොකද මේ හරි ඇඩ්‍රස් එක මට මේ මම අර ඔයගොල්ලන්ට Google Sheet එකක් දුන්නා. Google Sheet එකේ හරියට ෆිල් කරලා තියන්න. හරි. ඕකේ. ඕකේ. මේක එක පොතක්. ඊළඟට ප්‍රොෆෙසර් ගී කියනගේ there are several books of Professor G. G.C.E.A. පුතා. He has written books on unit price book. Okay, unit price book. But he has written up to unit 3. I couldn't found after that unit. He has written up to unit 3. So there are some books of Professor G.C.E.A. in English medium. So you can refer those books too. Okay. Then if you consider past paper books, there's a publisher called Pesuru. I think Pesuru books are very good because they have classified past papers into units. So once you did some units, you can follow the Pesuru books and you can do the past papers, past paper question in that units. So Pesuru books are Pesuru past paper books. Okay, Pesuru past paper books. If you want to buy these books, I think it is better to buy the classified past paper books. Classified past paper. Classified dot. Okay. මේ පොත් ටික හොඳට මතක තියාගන්න විශේෂයෙන් මේ ප්‍රොෆෙසර් රෝසාගේ පොත් ටික ප්‍රොෆෙසර් ලෝක ඒ පොතක් මම හිතන්නේ 5000ක් විතර එනවා. මේ පොත් දෙක මතක තියාගන්න අනිවාර්යෙන් අරන් තියාගන්න. මේක අතිශය වැදගත් පොත් දෙකක්. මොකද මම පාස් පේපර්ස් කරනකොට කියා දෙන්න. හරිද? තාම පොඩි වැඩි ඔයගොල්ලෝ. හොඳයි. ඕකේ. මම කීකියා හිටියේ ඔයගලන්ට අවශ්‍ය පොත් ටික ඊළඟට මම කිව්වේ කොහොමද අපේ ක්ලාස් එක ස්ට්‍රක්චර් වෙන්නේ ඉස්සරහට කියලා. ඉස්සරහට ඔයගලන්ට ඇත්තටම next year මේ වගේ වෙනකොට ඒ කියන්නේ ජූලයි ඔගස්ට් විතර වෙනකොට රිවිෂන් ක්ලාසස් and පේපර් ක්ලාසස් පටන් ගන්නවා පුතේ. එතකොට ඔයගලන්ට ලොකු වැඩ ටිකක් තියෙනවා. අනිවාර්යෙන් ඔයගොල්ලෝ අඩුම ගානේ 3 පාරක්වත් පේපර්ස් කරනවම තමයි. 3 පාරක්වත් පේපර්ස් කරනවම තමයි. ඒ නිසා හොඳට මතක තියාගන්න මේ මුලින් ඉඳලම අල්ලගෙන ඉන්න. හොඳයි.
Sir,
Okay. Do you have any question?
sir, what's that Professor G.C.E.A? What's the name?
Professor G කියනගේ පුතා. Professor G කියනගේ.
G.C.E.A.
Professor G කියනගේ.
What's under that, sir? Unit.
Unit price. because he has written so many books. All of them are unit test books for English medium students. Okay, single medium student there are a lot of books written by Professor G.C.E.A. But English medium
Yes, sir. Thank you, sir.
students, there are few books. All the books are unit test books up to the unit 3. As I remember, up to the unit 3, he has written in English medium. Okay. So you can refer those books if you want to improve your theoretical knowledge. These books are very good. But if you want to improve your mathematical ability and how to solve examination questions, these 2 books are excellent. Okay. Okay. Shall we go to the lesson? Okay. Last time we have discussed about prefix. Okay. I'm going to explain what we'll learn in today's class. First, we will recall our knowledge about prefix. Then, last time we have discussed there are 2 kind of prefix: multiples and submultiples. Multiples and submultiples. We will discuss them too. Then, after that, after completing of prefix, we will learn rules of writing SI symbols. There are some rules, Puta. There are some rules to write SI symbols. So we will discuss that part after completion of prefix. Then after completion of these 3 parts, we will complete our first part of the our unit 1. Then we will discuss the most important part of the unit, that is dimension. Dimension and dimension analysis. We will discuss this one after completion of prefix. Under the dimension, we will discuss the definition of dimension and how to derive a dimension of a physical quantity. Then the application of dimension. Okay. I think we won't be able to complete all the application within today, but we will complete 1 or 2 applications within today. So those are the parts that will be discussed during today's class. Prefix, then rules for writing SI units, then dimension. Okay. Last week, we have discussed about prefix. Okay, you know, there may be some occasions we have to measure some large scale physical quantities or some small, very small amount of measurements. So larger measurements and small measurements. So we have to measure larger measurements and small measurements. So our defined SI units may not be sufficient to measure those kind of large scale measurements or small scale measurement. As example, distance from Earth to Moon. We cannot use meter, no? Then distance on atomic radius. Atomic radius cannot be measured by meter ruler. So those kind of large scales and small scales measurement cannot be measured. Actually, not cannot be. It is very difficult to measure using defined FI units. So in such cases, we have to convert our defined SI unit to a large scale units or to a small scale unit. So we are going to convert the SI unit to a large scale or a small scale. If we want to find, if we want to measure a very large amount of measurements, we have to convert our SI unit to a large scale scalar. If we want to measure a very small measurement, we have to convert our SI scale to a small scale. In this case, if we want to convert the SI scale to a larger scale, we have to multiply the SI scale by some factor. If we want to measure, or if we want to convert the SI scale to a smaller scale, we have to divide the SI scale by some factor. Those are the things we have discussed last week. So if we want to convert the SI unit into a larger scale, we have to multiply with that. As example, if we want to convert meter to a larger scale, we can multiply meter by 1000. If we multiply 1 meter by 1000, we will have kilometer scale. If we multiply the meter scale by 1000, we will have kilometer scale. So we have converted the meter scale to a kilometer scale. Then, if we want to measure very small scale length, we can convert meter scale to a millimeter scale. We can convert. So if we divide the meter scale by 1000, we will have millimeter scale. So if we multiply the SI scale by some factor, we will have a larger scale. If we divide the SI scale by some factor, we will have a smaller scale. That is the argument, or that is the logic. Okay, what is the logic? We want to measure, we understand very well that one. We have to measure a larger scale measurement or a small scale measurement. That is our objective. Okay, so we cannot use the original SI system, the original SI scale, to measure a larger scale or to measure a small scale. We cannot use the original one. So we have to convert the original one. If we want to convert the original one, we have to multiply or divide. If we multiply the original system, we will have a larger system, larger scale. We have a larger scale. If we divide the original system, we will have a smaller scale, a small scale. Okay. So the factor that is used to multiply or division, division, can be indicate using a symbol. Can be indicate using a symbol written in front of the original symbol. So this symbol is called as a prefix. This prefix. So prefix represent the multiplication or division factor. Division factor during the conversion of SI units. Okay. I think we have done up to now this level, no?
Yes.
Okay. 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 We can summarize this thing, Puta. We can summarize that thing. Okay. Here our SI system, SI scale. We can convert the SI scale. We can convert the SI scale. We can convert the SI scale to a larger scale. Or to a small scale. If we want to convert the SI scale, if we want to convert the SI scale into a larger scale, we have to multiply. We have to multiply. We have to multiply the SI scale. If we want to convert the SI scale into a small scale, we have to divide the SI scale by some factor. Okay. If we multiply the SI scale by some factor, we call them as multiples. We call them as multiples. If we divide the SI scale by some factor, those factors are called as submultiples. Submultiples. Multiples and submultiples. Okay. The multiples and submultiples, that factor can be represented using some simple letter or capital letter, some English letter. Okay. That letter is called as a prefix. That symbol is called as a prefix. So submultiples and multiples are called as prefix. Prefixes. Okay. You can summarize what we have learned last week as this. Okay. This is a summary. Okay, write it. Example. Example, if we multiply meter scale by 1000, we will have kilometer scale. If we divide the meter scale by 1000, we will have millimeter scale. Millimeter scale. Examples. Once you note down this one, may please let me know, Puta. Give me a thumb. Good. Those are the two books written by Professor Rosa. MCQ books, okay? Professor S.R.D. Rosa. These books for English medium students, otherwise he has written from 1994 to up to 2022 for single medium students, but for English medium students, we have only those two books. Okay. Have you done this? Shall I erase?
Okay, sir.
Okay. Okay. Now we can write some examples for prefixer. Some multiples and submultiples. Okay. There are some multiples and submultiples, Puta. Now we are going to write their names and the multiplication factor and the symbol. Name, the multiplication factor and the symbol. Beta and exa. Okay. Those are the multiples. Okay. Deca, hecto, kilo, mega, giga, tera, peta, exa. Okay. I think you can remember from this to this. Kilo, mega, giga, tera, peta, because when we are discussing about the capacity of computer or some our pen drives or hard drives, normally we start with byte, no, byte, then kilobyte, megabyte, gigabyte, terabyte, no. You can remember in that way: byte, byte, kilobyte, megabyte, gigabyte, terabyte, no. So then kilobyte, megabyte, not byte, okay, kilo, mega, giga, tera, peta, exa. Then additionally, we will have deca and hecto. Deca means the multiplication factor. The multiplication factor is 10 to the power 1. 10 to the power 1. Multiplication factor is 10 to the power 1. And the symbol is DA. DA, simple DA. Hecto, the multiplication factor. The multiplication factor is 10 to the power 2. The symbol is simple H. Simple H. Kilo. Kilo. The multiplication factor 10 to the power 3. Multiplication factor 10 to the power 3. The symbol simple K. Simple K. Okay. Then mega. After this level, after the kilo level, the multiplication factor will come by 10 to the power 3 times. 10 to the power 3 times. Okay. Then 10 to the power 6. Then 10 to the power 9. Then 10 to the power 12. 10 to the power 15. Then 10 to the power 80. 10 to the power 80. The symbol of mega is capital M, Puta, capital M. The symbol of giga is capital G. The symbol of tera is capital T. I think you can remember that one. Peta, capital P. Exa, capital E. Capital E. Then the second column. Sorry. First one. Deca, it will become deci. Deci. Hecto will become centi. Milli. It will become micro. Micro. Nano. Pico. Femto. Atto. Femto, okay. Femto. Atto. Femto. Atto. Ten to the power minus 1, okay. 10 to the power minus 1. That means it will be divided by 10. Simple D. Centi, 10 to the power minus 2. Simple C. Milli, 10 to the power minus 3. Simple M. Micro, 10 to the power minus 6. Mu, okay. This is a Greek letter, mu. Nano, 10 to the power minus 9. Simple N. Pico, 10 to the power minus 12. Simple P. Femto, 10 to the power minus 15. Simple F. Atto, 10 to the power minus 18. Simple A. Okay, those are the multiples and submultiples. There are a lot of things, but that is enough for A levels. Okay. Okay, note down this table. Okay. I will explain the rules, Buta. I will explain the rules. Okay. When I'm explaining the rules, I will give the answer for your question. because simple P, okay? Because we use capital P for beta. This is a simple P. Okay. How may I write down this one? Shall I clean the board? Okay, I will wait. Once you note down the table, please give me a thumb, okay? Good. Others? Atto, okay? Atto. කොල්ලෝ ටික. Have you done? Or is she writing? Okay. ඊළඟට පොඩි වැඩක් කරන්න තියෙනවා පුතේ ඔයගොල්ලෝ. මේ මේක ලියනකම පොඩ්ඩක් අහගන්න. මම පොඩ්ඩක් වැත්ත කරලා කියන්නම්කොනේ. මේ අද ක්ලාස් එක වුණාට පස්සේ කට්ටියම අද වෙනකන් කරපු නෝට් එක ඔයගොල්ලෝ ලියාගත්ත නෝට් එක මට පොඩ්ඩක් ෆොටෝ ගාලා වෙන වෙනම WhatsApp කරන්න. වෙන වෙන WhatsApp කරන්න. මට පොඩ්ඩක් බලන්න ඕනි. මොකද මේ ඔන්ලයින් ක්ලාස් වල තියෙන එක දෙයක් එක ඩිස්ඇඩ්වාන්ටේජ් එකක් තමයි මට ඔයගොල්ලන්ගේ පොත් බලන්න වෙන්නේ නැති එක. හැබැයි වුණාට මට ඒක නොකර ඉන්න බෑ. ඒක නිසා මම අනිවාර්යයෙන්ම ඔයගොල්ලෝ පොත් බලන්න ඕනි. ලියාගත්ත දේවල් ටික. ඒක නිසා මට පොඩ්ඩක් ඒ ටිකේ ෆොටෝස් අරගෙන මට වෙන වෙනම WhatsApp කරන්න ගෲප් එකට දාන්න එපා. වෙන වෙනම WhatsApp කරන්න මට පොඩ්ඩක් බලන්න. සිංහල මීඩියම් කට්ටිය මට එහෙම කරා. ඕගොල්ලෝ පොඩ්ඩක් කරන්න. නෑ නෑ. දිගටම පුතේ. ෆුල් නෝට් එක. ෆුල් නෝට් එක. අද නෝට් එක දාන්න නෙමෙයි. ඕකේ. Okay. I will clean the board, okay? Is she writing? Deca, hecto, kilo, mega, giga, tera, peta, exa, deci. Actually, those are the three prefixes you have to remember because some children will be confused of those prefixes because those have some similar names. Deci, deca, deci, deca. Maybe It will confuse. Deci, deca, hecto, centi. Okay. Shall we move to the other part? Okay. The next segment is rules of writing SI symbols. Rules of writing SI symbols. Okay, Puta. There are some rules because we have to write the SI symbols. We have to write SI symbols in accordance with that rules. Okay. First one is if the SI unit represent a name of scientist, if the SI symbol represent, if the SI unit represents a name of scientist, then the symbol beginning with a capital letter. As example, Kelvin, Newton, Hertz. The beginning letter, the first letter should be a capital letter. So if the SI unit represents a name of scientist, then the SI symbol begin with a capital letter. That is the first rule. Second one. All the other SI symbols should be start with a simple letter. Gram, meter, gram, then seconds. Those are not the names of scientists. So the symbols should be started with a simple letter. Okay, that is the second rule. Third one. I think we have discussed this one. When we are writing a SI unit for a derived physical quantity, there should be a gap or a small space in between two SI units. Which are used to measure the physical quantities that are used to derive the SI unit. They are the physical quantity. Okay? That's mean force equal MA. So force equal MA, no? So M and A are the physical quantities that are used to derive force. So when we write the physical SI unit of this physical quantity, we should leave a space in between those those SI units. So kilogram is used to measure kg. Sorry, kilogram is used to measure a mass. Then meter is used to measure length. Second is used to measure time. So we should leave a gap in between those physical quantities. Symbols, okay? Not physical quantities, symbols, okay? Okay. When we are writing a SI symbol of a derived physical quantity, we should leave spaces between the SI symbols of physical quantities that are used to derive the particular physical quantity. That is the third one. Fourth one, if we use a prefix with the SI units, there should not any space between the physical SI unit and the prefix. Kilometer, millimeter, okay, millimeter. So there should not be any space between a prefix and the SI unit. Okay. As example, MS. Is there a difference between those two? Is there any difference, or are they represent the same physical quantity? Is there any difference? Is there any difference between them? Is there any difference between them? Give me answer. What is this one and what is this one? How to read both of them? How to read? How to read this one and how to read this one? Is there any difference between those? First one, milliseconds. Second one,
meter seconds.
Meter seconds. Very good. This is milliseconds. Milliseconds mean we can use this one for measuring time. This is a time. But this one, meter second. That is a multiplication between a length and time. So those two represent two different physical quantities. This one represents a time. This one represents a multiplication between a length and time. That's why those rules are so important, because we have to obey to these rules when we are writing physical SI units of physical quantities. Okay. Otherwise, there may be two different meanings. There may be different meanings. We can write millisecond. We can write millisecond in this way or in this way. But if we write millisecond in this way, definitely there will be a different idea. Okay, different meaning. That is a problem. Okay, so when we are writing a SI symbol with a prefix, we should not leave a space between them. Okay. Okay. Then other one, fifth one. This is not so important, but we have to obey this one. Okay. When we are writing a SI symbol after number, we should leave a space. We should leave a space. Don't write it as like this. Don't like this. Okay. Don't write like this. We should keep a space. We should leave a space between them. Okay. Those are the 5 rules we have to obey when we are writing SI symbols. Okay. Okay. Write the topic, rules of writing SI symbols. Rules of writing SI symbols. First one. If the SI unit, 3%, 3%, a name of a scientist, the symbol will be started with a capital letter. The symbol will be started with a capital letter. Examples.
So the symbol will be
Started with a capital letter. Started with a capital letter. Examples: Kelvin, Newton, Hertz. There is another rule. I forgot to mention that one because you have one of you have asked this question. Suppose if we want to write this SI symbol in a word, when we are writing the SI symbol, in words, we have to use simple letters only. Okay. Kelvin, Newton, gram, meters. For all the SI units, for all the SI units, when we are writing the name of the SI unit, when we are writing the name of the SI unit in words, we have to use simple letters only. We have to use simple letters only. Okay. Okay. Second thing. In all the other cases, SI units are started with simple letters. We can write these examples. Meter for meter. S for seconds. Yes, I will send the recordings last week and May this week. Okay. Third one. One space is left. One space is left. One space is left between two SI symbols, of physical quantities, two SI symbols of physical quantities that are used to derive, that I 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 used to derive, used to derive a derived physical quantity, used to derive a derived physical quantity. Okay. When we are writing the unit of speed, there should be a space in between meter and per seconds. Meter and per seconds. This should not be like this, okay? Yeah, I think you want to write the whole unit in word, no? That is your question, no? You want to write, yeah, you want to write kilogram in word. If you want to write kilogram in words, all the letters should be simple letters. Okay. If you want to write mega Newton, if you want to write mega Pascal, all the letters should be simple. Okay. But their symbols may be capital. Okay. Mega meter means capital M, simple M, megameter. But if we write this in a word, we should write megameter. Mega, okay. Megameter. Okay. Kilogram. Kilogram. Okay. When we write in a SI unit in a word in words, we have to write them in simple words. Okay. Do not use any capital letter. Okay. This is the example. And this is third one. Fourth one. When writing a SI unit, when writing a SI unit, when writing SI unit, with a prefix, the prefix should be written should be written, should be written should be written in front of the SI symbol, 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 without leaving a gap, without leaving a gap, without leaving a gap. Millimeter. අපිට ඕන අර නෝට් එකක් දාගන්න පුළුවන් අර විදියට. This is equal to milliseconds. But this is equal to, if there is a gap, this is equal to meter seconds, meter seconds, meter seconds. So difference is, this is a time, this is a time, and this is a length into time, length into time. This is a time while this is length into time. This is a not talking.
Excuse me, sir.
Okay.
Sir, what was the second law, second rule you said? I just missed it. Sorry, sir.
All the others, no. First rule is, if the SI unit represent, if SI unit represent is a name of scientist, that is the first rule, no. The second rule is, all the other SI symbols will be started, all the other SI symbols will be started with the simple letter. All the other SI symbols will be started with a simple letter. All the other SI symbols will be started with a simple letter.
Okay, sir. Thank you.
Okay. Because in the first rule, I have discussed about the capital letters. That means the SI symbols represents a name of scientist. The second rule indicates all the other symbols. Okay. This is the fourth one, no? Fifth one. Have you note down this one? Still writing, no? Shall I clean the board?
Okay, sir.
Okay, very good. Okay, fifth one, fifth rule. One space, fifth rule. One space is left. One space is left one space is left between a numeral and the side, between the numeral and the side. You can write this example. When we are writing 10 kg, we have to leave one space between 10 and kg. Do not write 10 kg as a one letter. Okay. Sixth one. Sixth one. When writing the name, when writing the name of a SI symbol, when writing the name of a SI symbol, when writing the name of a SI symbol, in words, all the words should be simple letters. All the words should be simple letters. Examples: kg, kilogram, meter per second, ms minus 1, meter per seconds. Okay. when we are writing SI symbols in words, we have to write them in simple letters.
Sir, can we write kilogram as one word?
Kilogram. Kilogram is not a one word, no? Kilogram. It is not a one word. I think that is kilogram means two words. Put a kilogram, kilometer, kilometer. Okay. Can you remember the SI units? Can you remember the SI unit of fundamental physical quantities? SI units of fundamental physical quantities. Hmm? Hmm? Can you remember? Can you remember? Okay. Length. Length. What is the fundamental SI units? Length. For length. Length. Meter.
Meter.
Then mass. Kilogram. Then time. Seconds. Then temperature, Kelvin. With then current, ampere. Then number of amount of substance, mole. Luminous intensity, candela. Okay, among those SI units, there's a one is specific SI unit. There's a one is specific SI unit because that SI unit use a prefix. What is that? What is that? All the other physical quantity SI units are base units.
Kilogram.
Yeah, but kilogram, but the SI units that is used to measure mass is kilogram. That means we use a prefix with that unit. So that is the only unit, only SI unit, the only SI base unit, okay? Not only SI unit, that is the only SI base unit with the prefix, okay? I think you have to note down that thing as a note, another note. Notes are the things you should remember as important points, okay? Okay, note down. The only fundamental physical quantity, the only fundamental physical quantity the only fundamental physical quantity the only fundamental physical quantity which uses a prefix, which uses a prefix. Which uses a prefix? Is mass. Is mass. Is mass. Is mass. The SI unit of mass is kilogram. The SI unit of mass is kilogram. Kilogram. Okay. Okay, Buddha. There are some another important points. There are some another important point. Okay. Let me know. What is the power of a number? What is the power of number? Can someone explain to me? What is the power of a number? Power. Indices. We call sometimes indices. What is the power of a number? Can someone give me the answer? What is the power mean? Power means
The number that represent the number that represent the times that the particular number has been multiplied by itself.
yes, very good, very good. That is the best answer, Buddha. That is the best answer. Because if we multiply 2 by 2 by 2, let's say we multiply 2 by itself in 4 times, we can write it as 2 into 4. 2 into 4. This is a shortcut method. This is a shortcut method to represent this one. To represent this one. Because let's say we have to multiply 2 in 100 times. Can we write this one? Can we write that one? We cannot write that one, no? So, this is the shortcut method to represent this one. Represent this one. So, power is the time. Power is the number of times these two multiply by itself. In this case, there are 4 2's. There are 4 2's. So, we will write 2 to the power 4. 2 to the power 4. So, what I want to say is, suppose there's a power. Suppose there's a power. A to the power m. Suppose there's a power. So, power should be a number, Putta. So, power should be a number because this represents the times of the times multiply this base by itself. This is called as base, no? So this represents the times, number of times multiply this base number by itself. Okay. So the power represents a number only. So if there is an expression a to the power m, if there is an expression such as a to the power m, we can definitely say m is a number. We can definitely say m is a number. Do you understand me? Do you get my point? Okay. So if there is a power, Puta, if there is a power, this one should be a number. It should be a number. So if it is a number, number is not a physical quantity. So it's a scalar number, just a scalar. No? So it is not a physical quantity. That is the important point. So if there is a power, that is a number. Number is not a physical quantity. Number just a number. It is not a physical quantity, no? It is not a physical quantity. It is just a number. So suppose we are given this kind of expression. A to the power bx plus y. A to the power bx plus y. A to the power bx plus y. So we can say, as this is a power, this part, this bx plus y, the bx plus y part is a number. It is a number, Puta. It should be a number. So this is not a physical quantity. This is not a physical quantity. This is just a number. So number doesn't have a unit, no? Number doesn't have a unit. So if there is a power, this expression does not have a physical quantity. It does not have a unit, okay? Not a physical quantity. Unit. Because this is just a number, this is not a physical quantity, Buddha. Okay? There may be unit for B, there may be unit for X, there may be a unit for Y, but the whole part, just a number. Okay? Did you get my point? Should I explain that one again? If you understand, please give me a yes. Okay, very good. So what I was saying is, if there's a power, is just a number is not a physical quantity. So a power, if there is an expression as a power, if there is an expression as a power, this expression does not have a unit because it is not a physical quantity. This is another knot, okay? It is another knot. Not one. Two to the power 2 into 2 into 2 into 2. We can write it as 2 to the power 4. 2 to the power 4. So if we take 2 to the power 4, this is the number of times. This is the number of times. Number of times that the base unit is multiplied by itself. Okay. So the power is just a number. So the power is just a number. Okay. So therefore, the power is just a number. You can write down this one. Not therefore, the power is just a number. Okay, right under this, so if there is an expression, if there is an expression, if there is an expression so if there is an expression as a power, as a power, as a power, as a power, that expression does not have a does not have a unit, does not have a unit. Example, suppose there is a term a to the power pq over r. So the expression pq over r is a number, so therefore pq over r does not have a unit. Okay, then suppose 2 to the power 4 is equal to what? Suppose 2 to the power 4 is equal to what? Then we can write this as a logarithm function, Putta. How to write this as a logarithm function? How to write this as a logarithm function? Give me answer. Give me an answer. How to write this as a logarithm function? I think you have done this in your, no? Okay. No. Don't take logs into two sides. I want to write this as a logarithm function. Don't take log in two sides. Okay. How to write this in log way? Log.
Y dash 2 equals 4.
Sorry.
Y dash 2 equals 4.
Log. So what is the base of log? Okay. No. In this case, base is 2, puta. Base is 2. So we can write the base of logarithm function as 2. 2. Then the log logarithm function, the base is 2. Then y is equal to 4. Can't you remember this one? How to write this? How did you write this one? How did you write this one? Log base 10 100 is equal to. How to write this one? I think you have done this one, no?
Yes, we have done this.
Very good. You have very good memory, okay? That's why I want to do basic mathematical concepts, okay? I will continue that turn. Okay. Okay. Log. If we are given a power, we can write that power as a logarithm function. Okay. So this logarithm function is also equal to a power. It is equal to a power. No? This logarithm function also equal to a power. That means it represents the number 2. This represents the number 2. So logarithm function also represents a number, Buddha. It's just a number. That means the logarithm functions also not a physical quantity. Do you understand? Those are just numbers. So those are not physical quantities. So if we have a logarithm function, that expression should not have a unit. Should not have a unit because it is just a number. It is just a number. Okay. I think you get me. Do you get me?
Yes, sir.
Very good. So the logarithm function represents a number. That means they don't have physical they are not physical quantities. That means they do not have units. Okay. My second note. Not 2. To the power y, we can write it as a logarithm function. Write this one. Okay. Okay. That means right under this one, right under this one, right under this one. First, you have to write these two, and right under this one. That means logarithm functions represent numbers two. Therefore, they are not physical quantities. They are not physical quantities. Therefore, they do not have units too. They do not have units too.
So what about the power of a mass?
Sorry?
So then what about the power of mass? It has units too.
Power of a
Mass, a certain mass.
no. The power of a mass means you means m squared or something.
Yeah.
No, Buddha. The in this case, I have mentioned in different meaning. Okay, that's mean something like this. A to the power 2. A to the power 2 is a number, no? So m to the power 2. This is the power of mass, Buddha. The power of mass. This is a number, no, Buddha? No. Do you understand? The power is a number. Power is a number. Okay? Don't you understand?
Okay, sir.
Okay?
Yeah, sir.
When you getting the power of a mass, the power is a number, Buddha. Power is a number. So if we have an expression, such as this, if we have expression something like this power should be a number. That is my argument. Okay. This one, a to the power bx plus y, this might be a physical quantity. The whole thing might be a physical quantity. But the power should be a number. That is the point. Okay? If you square in a mass or if you square in a length, when you are calculating area, you will square in the length. No. So when we are squaring a physical quantity, you can square. But this power is just a number. That is my argument. Okay.
Okay, sir. Yeah.
Others? Do you have any question? Very good question. Okay, very good question. Yeah, that one. Do you have any question? When we are getting a power, that power indicates a number. That indicates a number. So if there is an expression, okay, if there's an expression as a power, there should be a number. That is my argument. Okay, that is my argument. Okay. Okay, Buddha. Then this, suppose there is an expression a b plus c p plus q, something like this. So if there is an expression within a logarithm function, this should be a number. Okay, this should be a number. Because logarithm function does not have a unit because it is just a number. So according to that, this one ab plus c does not have a unit. It does not have a unit. ab plus c is a number. So ab plus c, therefore ab plus c doesn't have a unit. Do you get my point? If there's any question, if there's any question, Putta. This is the example. If anyone has a problem, please let me know, because we should clear all the things, Putta. Do you have any question regarding this? Okay. Did you understand this one? Please let me know if you get. Okay. Others? Do you have any question regarding this? I think we can do a lot of questions using this argument, okay? Especially in dimensions. Okay. The last part of this one. Okay. I think you may know there are some physical quantities. They don't have units, Putha. They don't have units because when they are deriving, we use same physical quantities in a ratio. If we use same physical quantity as a numerator and denominator, the units of both physical quantity will be cancelled out. So the derived physical quantity will not have a unit. Okay. We can use some examples. Relative density. Relative density. Relative density is defined as the ratio between the density of a substance to the density of the water. Density of the substance. Density of a substance to the density of the water. Density of water. That is the definition of relative density. According to the definition of relative density, there is a ratio. The both numerator and denominator represents the same physical quantity. In this case, densities. No, in the numerator represents the density. The denominator represents the density too. So the both numerator and the denominator represent the same physical quantity. So the units of density means kg m minus 2. No? So kg m minus 2. So units of numerator and denominator will be cancelled out. So the derived physical quantity won't have a unit. Okay. So there are several physical quantities. They don't have units because the reason is the way of their definition. Actually, the way of derivation. The definition of this physical quantity. That is the reason for this scenario. Okay. Doesn't have a unit. Okay. Another note number 3, no? I don't remember number 3 or number 4. No, number 3 or number 4. I don't remember the number. The next note is okay. Do not try this one. I will give a note. Some physical quantities some physical quantities do not have unit. Do not have units. The reason is the reason is the way of derivation. The way of derivation. The way of derivation. You can write this example. You can write this example. Relative density. Sometimes we call this as specific gravity. Specific gravity. Specific gravity. Both names are same. Okay. Specific. Specific gravity. Specific gravity. Specific. Both are same words. Okay. Once you write down this, please let me know. Good. Others? Okay, Buddha. Relative density equal density of a substance over density of water. Density means kg m minus 3. Kg m minus 3. Both will be cancelled out. So the relative density doesn't have a unit. Okay, I will give some physical quantities that doesn't have units. Okay, write some examples. After writing this one, write these examples under this relative density of first one. The second one, refractive index. Refractive index. Refractive index. Refractive index.
Sir, so basically these are ratios, no, sir?
Yes. All of them are ratios. Ratios. That's why the units of numerator will be cancelled out the units of denominator. That's why they don't have physical units. Okay. Refractive index. Refractive index. Then second thing, efficiency. Efficiency, you know both of this. Efficiency. 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 Strain. 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 Length over length. I will give that one. Strain. Relative permittivity. Relative permittivity. Relative permittivity. Relative permittivity. Coefficient of friction. Coefficient of friction. Coefficient of friction. Those are some physical quantities. They don't have units. Have you noted down this one? Good. Once you finish, please let me know. Okay. Please let me know. Good, good, good. Okay. Okay. Okay, Buddha. Shall we go to our next lesson? This lesson means the most important lesson in Unit 1, that is dimensions. Dimensions. Dimensions and dimension analysis. Dimensions. That is our main topic, dimension and dimension analysis. Dimensions and dimension analysis. That is our main topic. Dimension and dimension analysis. Okay. Actually, this is about derived physical quantities, especially about derived physical quantities. Dimension. Dimension means actually when we are discussing about derived physical quantity, such as speed, or we know the speed. The speed is defined as length over time. Length over time. That is the definition. Okay. But when we are discussing about length, we cannot get the understanding about the physical quantities that is used to define the speed. That means if you know the definition of speed, then definitely you know the speed is length over time. Suppose you don't know about the definition of the speed. Suppose you do not know about the definition of the speed. So when we are discussing about speed, you do not know what are the physical quantities that are used to derive this derived physical quantity. In such cases, there was a requirement. There was a requirement. If we can represent a derived physical quantity, using their fundamental physical quantities, using the fundamental physical quantity that are used to derive that physical quantity, then anyone can easily understand what is the definition, how they derive during their derivation. Then there was a requirement to represent a derived physical quantity using their fundamental quantities. Okay. So we cannot use the full definition. Actually, if we use the full definition, it might be very lengthy one. So we will use some shortcut method to represent the fundamental physical derived physical quantity, using the fundamental physical quantities that are used to derive that particular derived physical quantity. Okay. So that is called as dimension. The dimension of, understand that one, the dimension of a derived physical quantity represents the relationship between the fundamental physical quantities that are used to derive that particular derived physical quantity. As example, in this case, first we should define the dimension of fundamental physical quantity. In this case, we will use this symbol, Puta. We will use this symbol. You will understand after the completion of this explanation. Okay. Okay. We will use this symbol. We will use some symbols as the dimension of fundamental physical quantity. First, we have to define the dimension of fundamental physical quantities. Then we can derive the dimension of derived physical quantity. In this case, we will define the dimension of length. Dimension of length as L, as capital L, and dimension of mass as capital M. Dimension of time as capital T. We will define the dimension of those fundamental physical quantities first. After that, we can define the dimension of derived physical quantities. So the dimension of derived physical quantities represent the relationship between the fundamental physical quantities that are used to derive that particular derived physical quantity. As example, we can write the dimension of speed. How to write the dimension of speed? We know the dimension of length is L, and we know the dimension of time is T. Dimension of time is T. Then we can write the dimension of speed L T minus 1, because if I bring this T to the numerator, it will be minus T. So we can write the dimension of speed is as LT minus 1. LT minus 1. That means so if we are given the dimension of some physical quantity as LT minus 1, that says there is a length, and length should be divided by time to obtain that derived physical quantity. Okay, there is a length, and if we divide that length by time, we can derive that physical quantity. Okay, so the dimension of a derived physical quantity represent the relationship between the fundamental physical quantities that are used to derive that particular derived physical quantity. So we cannot remember all the definition of derived physical quantities, but if we can understand the dimension, of that particular derived physical quantity, we can understand the definition of that derived physical quantity. Suppose we have a physical quantity A. I don't know the name of that physical quantity, but we are given the dimension of that physical quantity is ml minus 3. ml minus 3. That means this physical quantity is derived something like this, no? ml minus 3 means m over L3, no? M over L3. M means mass. L3 means 3 times length. This is mass. This is 3 times length. Length by length. No? That means volume, no? Mass over volume. So we can understand this is derived as mass over volume. mass over volume. So dimension, the dimension of a physical quantity represent how they connect with fundamental physical quantity. From dimensions, we can easily define that physical quantity. Easily define. So, if we want to find the dimension, the dimension of a physical quantity, first we should define the dimension system for fundamental physical quantities first. That is my first argument. If we want to define a dimension for a derived physical quantity, we should define dimension for fundamental physical quantities. In this case, we have defined the dimensions of the dimension of length. Normally, the dimension is represented using square brackets. Square brackets, okay? I will give that in our note. Dimension is represented by the square bracket, So, dimension of length can be written in this way. So, this represents the dimension of length. This is not the length. This is dimension of length. If we use square brackets, that means the dimension. So, this represents the dimension of length. So, we have defined the dimension of length is equal to L. Then, the second one, mass. The dimension of mass is equal capital M. That is very simple thing. L means length, M means mass. M no. Then time. The dimension of time mass capital T. Okay. Those are the three main fundamental units in mechanics and properties of matter and in our yellow syllabus. So, normally we are defining those three fundamental physical quantities only. Okay. Others are not in our syllabus, but some cases we are given the the dimension of temperature as theta, the dimension of current as capital I. That may be given, but thing is that is not in our syllabus. But in our syllabus, those are the three main fundamental physical quantities that are used in especially mechanics and properties of matters and some part of waves. So most of the syllabus are covered by these three fundamental physical quantities. So we are going to learn about these three dimensions only. So we are going to find the dimension of derived physical quantities using those three fundamental physical quantities only. So our target is very easy, because if there are 7 physical quantities to be considered, then there may be a lot of derived physical quantities. Okay, but we are limited to these three physical quantities. Okay. Okay. Then again, dimension is what? Dimension is a relationship. Actually, dimension represents a relationship between the fundamental physical quantities that are used to derive a particular derived physical quantity. So if we want to define the dimension of a derived physical quantity, we should first define the dimensions of fundamental physical quantities. In that case, we have defined the dimension of length is L, dimension of mass as M, dimension of time as T. Okay. From those are the main three fundamental physical quantities. So in our A-level syllabus, we are going to learn these three only. Okay. So now we are going to determine the dimension of derived physical quantities using these dimensions. Okay. Shall we go to do that? Suppose we have to find the dimension of velocity. Dimension of velocity. How to write that one? Velocity within square brackets. The dimension of velocity means velocity within square brackets. If we want to find the dimension of a derived physical quantity, first you should know the definition of that physical quantity. You should know that definition. How to derive that physical quantity. In this case, velocity. I think you know that one. How to derive velocity, Puta? What is the definition of a definition of the velocity? What is the definition of the velocity? What is the definition of the velocity? Yeah. Velocity. Velocity. Displacement over time. Very good. Displacement over time. So the dimension of velocity is equal the dimension of displacement over dimension of time, Puta. Dimension of time. So that is the way of deriving the dimension of a derived physical quantity. Then you can write this one. Displacement. Displacement is a length. What is the definition? What is the sorry. So what is the dimension of length, Puta? What is the dimension of length? Yes, here. Capital L over. What is the dimension of time? Capital T. In dimensional analysis, don't leave something like this. Okay, you have to get all the things to the numerator. Okay, you have to bring all the things to the numerator. So there is a t to the power 1 in denominator. If you bring this to the numerator, it will be -1. So L t minus 1. So dimension of velocity. So dimension of velocity is equal capital L, capital T minus 1. Okay. Do you understand? Or do you want any further clarification? Do you understand this? Okay. Please give me a thumb or yes if you understand this one. Okay. Others? Okay. This is the way of deriving the dimensions of derived physical quantities. First, we have defined the dimensions of three main fundamental physical quantities. Then we can define the dimensions of other derived physical quantities using M, L, and T. Okay. Okay. Let's do some examples. This is one. Other thing. Another one. Another one is volume. 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 How to define the volume? How to define the volume? Length into length into length. Length, length, length. So we have to multiply three lengths to find the volume. So what is the dimension of volume? Dimension of volume is dimension of length. Okay, dimension of, I think first we have to write this one, other then I can clean this one. Okay. Now up to this level, do you have any question regarding dimension, Putta? Do you have any question? Oh, come on. Okay, very good. Others? Others?
Okay, sir.
Okay, very good. Okay. Okay. I think you have written down the topic. Then under that topic, dimension analysis. Dimension analysis. Dimension analysis is a study. Dimension analysis is a study This is a study of representing relationship among physical quantities, between physical quantities. The dimension of the dimension of a derived physical quantity, the dimension of a derived physical quantity, derived physical quantity, derived physical quantity. Three persons, three persons, three persons, three persons. The relationship, the relationship, the relationship between the relationship between fundamental physical quantities, between the fundamental physical quantities, between the fundamental physical quantities that are used to derive the particular derived physical quantity, the particular derived physical quantity. In another paragraph, therefore, we have to define therefore we have to define
So therefore we have to define
therefore we have to define the dimensions of therefore we have to define the dimensions of fundamental physical quantities first. Fundamental physical quantities first. the dimension of the dimension of the dimension of the dimension of a physical quantity, the dimension of a physical quantity, the dimension of a physical quantity can be represented by a square bracket, by a square bracket. Okay, you can write down this table. The physical quantity dimension. The physical quantity is length. The dimension of physical quantity is equal to L. The physical quantity mass. The dimension of mass is equal to capital M. Then the dimension of time is equal to capital T. Write down this one. Do not write this one. Only the table. Okay. Write under this table. Write under this table. Dimensions of dimensions of dimensions of dimensions of dimensions of other fundamental physical quantities. Other fundamental physical quantities are not considered are not considered in A-level syllabus. Are not considered in A-level syllabus.
So other fundamental quantities, no, sir?
Other fundamental physical quantities are not considered in A level syllabus. A level syllabus. Most of the derived physical quantities, most of the derived physical quantities, most of the derived physical quantities most of the derived physical quantities in our syllabus, in our syllabus, in our syllabus, are developed by are developed by combinations of above three physical quantities, above three physical quantities. However, there may be some cases, last part puta. Okay. I will repeat this one. I will repeat that one. Okay. I will repeat that one. The last week means. However, there may be some cases. You asked that part or previous one?
The previous parts.
Previous one, no? Previous one means puta.
Most of the physical quantities that are in our syllabus are developed after that, sir.
Most of the physical quantities that are in our syllabus are developed by combination of the above three physical quantities. The combination of the above three physical quantities.
Okay, sir.
However, there may be some cases, that we are given 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 the dimensions of the dimensions of the dimensions of the dimensions of temperature and electric current. Temperature and electric current. Okay, our next topic. Now we have now we have defined the dimensions of fundamental physical quantities. Okay. Now we are going to determine the dimensions of derived physical quantities. In this case, we have to get some idea. We should know the definition of the derived physical quantity first. How they derive, we should know that. Okay. So when we are determining the dimensions of derived physical quantity, first of all, we should aware about the derivation of that derived physical quantity. That is the first thing. If we know the derivation, we should write that equation. We should write that equation with fundamental physical quantities. Once we write that equation, we can assign the dimension of fundamental physical quantities to their respective places. Okay. After that, we can simplify this expression and get the dimension of derived physical quantity. That is a way of dimension of derived physical quantities. Okay. Okay. My next subtopic is determine the dimensions of derived physical quantities. 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 Okay. In this case, our step number 1 is write in the equation that represent the relationship between derived physical quantity and fundamental physical quantity. That is step 1. After that, we can assign the dimensions of fundamental physical quantities to their respective places. Okay. Then we can simplify the expression and take the dimension of derived physical quantity. Do you understand what I said? You got my point? Or should I explain it again? No kata no sinatlas. Mugut tේරුන්නේ නැද්ද? Okay, good. Okay. Okay. So step number one. Write the relationship between okay. Definitely I will say. Write the relationship between the particular derived physical quantity between the particular derived physical quantity and fundamental physical quantities. Write the relationship between the particular derived physical quantity and the fundamental physical quantities. Example. We can write this example. Area. The relationship between area and the fundamental physical quantities are area is equal to length into length. Length. Length into length. Step 2. Assign the dimensions of fundamental physical quantities assign the dimensions of fundamental physical quantities to their respective places. To their respective places. Area. The dimension of area is equal to the dimension of length, to the dimension of length into the dimension of length. Dimension of length into the dimension of length. That's mean this is equal L into L. That's mean L square. L square. L into L. That's mean L square. So we can write the dimension of area is equal L square. L square. Dimension of area is equal L square. Then you can write this one too, okay? The second example, velocity. Velocity. The dimension of velocity is equal dimension of displacement or dimension of time. That means L over T. That means LT minus 1. So velocity, the dimension of velocity is equal LT minus 1. Okay, I will share. once you complete the writing, please determine the dimension of acceleration. Okay, dimension of acceleration, and let me know. Dimension of acceleration. LT minus 2, very good. Acceleration. The dimension of acceleration. We know the dimension of acceleration is equal velocity over time. Velocity over time. Velocity over time, no? So the dimension of acceleration is equal to the dimension of velocity over dimension of time. We have determined the dimension of velocity. We have determined this one. So we can use this one directly. We can use this one. So the acceleration, dimension of acceleration is equal LT minus 1 over T. So we can bring this T to the upper side. That means it will be minus 1. Minus 1 means minus 2. So the dimension of acceleration equal LT minus 2. LT minus 2. In the same way, we can determine each and every we can determine the dimension of each and every physical quantities, derived physical quantities. As example, force. So how to find the force? Force is equal mass into acceleration. Mass into acceleration, Putta. Mass into acceleration. So no. There's no rule about dimension. Writing the letters of dimension. Okay. So the dimension of force is equal to the dimension of mass into the dimension of acceleration, Putta. So the dimension of force is equal dimension of mass. Dimension of mass means m. It is equal to m. Dimension of acceleration. It is equal to LT minus 1. LT minus 2. LT minus 2. So the dimension of force is equal MLT minus 2. MLT minus 2. Those are some examples, okay? Those are some examples. Do you understand? Do you have any question regarding this, Puta? Do you understand how I derived these dimensions? Do you understand the way I derived the dimension? Okay. Now I'm going to finish the lesson. Okay, Puta? I'm going to finish the lesson. Finally, do you have any question, Puta? Do you have any question?
No, sir,
Okay.
understood, sir.
Okay.
Thank you, sir.
So, I have sent some questions to the WhatsApp group regarding dimension. There are 25 number of derived physical quantities, Puta, and I have mentioned how to derive those physical quantities. So you can use that equations. Try to derive the dimension of those physical quantities and send me the answers. Send me the answers. Okay. Okay. If you have any question, please let me know. If you have any question, please let me know, because now I'm going to finish the class today. Actually, 12:17. Because now I have to finish the class. If you have any question, please let me know. Otherwise, you can leave now. And please do the homework which I sent to the group. Okay. Thank you then. Do you have any questions? Please let me know. Okay. Okay, Puta.